So in this video, we're going to look at the area between two curves. So the area of the shaded region would be the area under f of x. So this is my f of x function. The area between that and the curve would be this whole region. If I wanted to find the area between these two curves, I would need to take out this part here. And that part is the area under g of x, which is equal to the integral from a to b of g of x. So what we do is they're going to have the same bounds, same start and end, but we're going to take the integral from a to b of f of x dx and then subtract the integral from a to b of g of x dx. And that's the same thing as if we just do the integral from a to b of f of x minus g of x. And that will give me the area between the two curves. So kind of the formal definition, if y equals f of x lies above y equals g of x from a to b, the area of the region between f of x and g of x from a to b is this function that we talked about. So it's going to be one of two cases. They're either going to give you the bounds or it's going to be where the two curves intersect. And we'll do an example of both. So we want to find the area between y equals 2x cubed minus 4x plus 6 and y equals negative x squared plus 2x plus 1. So you're going to graph them again in your y equals. So take a minute and plug them both in. I already have them plugged in. So you'll put the first curve in y1, the second curve in y2, and then you're going to graph it. Again, you'll have to play with the window. You'll want your x values to be like 1 to 2, but I do like from 0 to 4. And then graph it, I think I did, yeah, from 0 to 3. And then I left it at the Zoom standard, negative 10 to 10 for the y's, and then I could see it pretty well. And I went to second, again, second table. So second graph gives me the table, and that's going to help me plot more accurate. So you don't necessarily have to graph it, but some on the exam, you are going to be asked to graph. So it's good to get in that habit. So if I look at my table, I'm going to go from 0 to 2. It goes up to 14. So I'm going to go up by 2s. Okay, make sure you label your scale somewhere. Okay, so my first curve, the 2x cubed minus 4x plus 6 is this y1. So it's 0, 6. One, 4. And 2, 14. And then if I just look at it to get an idea of the shape, I think it looks like the min is like right before 1, but it goes here and then up. It doesn't have to be perfect. Okay, and this, you want to label them. So this is 2x cubed minus 4x plus 6. Okay, my second curve is this red one. Second, again, table. Then you can see it. So it's 0, 1, which would be here. 1, 2. And 2, 2. Nope, 2, 1. It goes back down. Okay, and again, I go to graph to get an idea. And we went from 1 to 2. So we're really finding the area just from here to here of this region. Okay, so we're going to use the f of x, g of x. So f of x in this case is this blue curve that's above, and g of x is this one below. We're comparing the y values, which one's higher on the y-axis. So I'm going to do the integral from 1 to 2 of this top function, 2x cubed minus 4x plus 6. And then I'm going to subtract the bottom function and take the integral of that. So first simplify to make it easier. Okay, so I'm going to do minus a negative x squared, so plus x squared minus 2x minus 1. Okay, I'm gonna combine like terms to make this easier. Okay, so I have 2x cubed plus x squared. I have a negative 4x and a negative 2x, so minus 6x, and then 6 minus 1, so plus 5. Then I'm going to take the integral of each one. So I have 2x to the 4th over 2 plus x cubed over 3 minus 6x squared over 2 plus 5x. Okay, I took the integral, so that sign goes away. I put the bar and then I go from 1 to 2 to indicate my bounds for the fundamental theorem. If I simplify, all right, this should be over 4. Over 4, because this should be over the new exponent. I get x to the 4th over 2 minus 6 divided by 2 is 3x squared plus 5x. You don't necessarily have to simplify, but it might make this part a little bit easier. So then I'm going to plug it in. 2 to the 4th over 2 plus 2 cubed over 3 minus 3 times 2 squared plus 5 times 2. That's all my upper bound. Minus, and then I'm going to do the lower bound. So put it in parentheses, 1 to the 4th over 2, 1 cubed over 3, 3 times 1 squared, and then 5 times 1. So put this, I just put this in my calculator. So take a minute to do that while I am. So the first part, I got 26 over 3 minus 53 over 6. And then I can subtract them. So I made a mistake. This should be 17 over 6. Because when I subtracted them, I got a negative, and you should never get a negative. If you do, it either went backwards or your curves are reversed or you made a mistake. Okay, so this equals 35 over 6. I recommend checking these because it's really easy to make a mistake. So to check it again, I would do math down to number 9. Okay, to do this in your calculator, you do the lower bound and then the upper bound. And it's up to you what you want to plug in. I'm going to do the simplified one because I'm pretty confident that I simplified it correctly. But if you're not, you can always do the first line. Again, don't ever put the function in after you integrate. It should be the original one given. And then put dx, hit enter. And hopefully, yep, and then we get the same answer. Now, if you have an old calculator, if I didn't say this, what you will say is it will say f int and then a blanking cursor. So if that's the case, what you do is you put in the original function, again, not after you integrate. So 2x cubed plus x squared minus 6x plus 5, comma. And then you do comma, and then you always put x because it's with respect to x, comma, lower bound, comma, upper bound. Okay, so it's always f int function, comma, x, comma, a, comma, b. A is always your lower bound, b is your upper bound. So if you have an old calculator, that's how you put it in your calculator. Okay, so that's how you do the area between two curves when there are bounds given for you. And then I'll do another example in the next video.